To find a wiring diagram for a 1985 Simplex Duct Detector housing, firstly contact SimplexGrinnell technical support by calling 1-800-746.7539 and providing them with the model number of the detector housing. Secondly, check online databases by searching for Simplex Duct Detector wiring diagram in databases such as NFPA, which is the National Fire Protection Association, which is Underwriters Laboratories, or the SimplexGrinnell website. Thirdly, consult with an electrician or fire alarm technician. If you have access to a qualified electrician or fire alarm technician, they may have wiring diagrams for older systems. Some additional tips may help too. To identify the faulty detector, use a multimeter to measure the resistance across the detector's terminals. An open loop will indicate an open connection. Inspect the test switch wiring. Remove the detector from the housing and inspect the wiring connections to the test switch. Ensure that the connections are secure and the wires are not damaged. Check the end-of-line resistor. If the test switch wiring appears correct, check the end-of-line resistor connected to the last detector and the loop. A faulty resistor can cause an open loop. When troubleshooting a fire alarm system, safety is the top priority. When dealing with fire alarm systems, it's important to understand some fundamental concepts related to wiring and testing. The wiring of a fire alarm system, particularly in the context of duct detectors and test switches, is designed to ensure reliable operation and facilitate maintenance. A typical fire alarm loop consists of multiple detectors wired in a series. The panel supervises the integrity of the loop by monitoring the current flowing through it. An end-of-line resistor is placed at the end of the loop to provide a specific resistance value that the panel expects to see. If the loop is broken, shorted, or the resistance is outside the acceptable range, the panel will trigger a trouble condition. Duct detectors are specialized smoke detectors designed to be installed in the ductwork of heating, ventilation, and air conditioning systems. They sample the air flowing through the duct to detect the presence of smoke. These detectors are crucial for early fire detection as they can identify smoke before it spreads throughout a building. A test switch is incorporated into the duct detector circuit to allow for convenient testing of the detector's functionality without having to introduce actual smoke. The test switch typically simulates the smoke condition, triggering the alarm and verifying that the detector and the fire alarm panel are functioning correctly. When troubleshooting an open loop, using a multimeter is essential. The multimeter can be used to measure resistance, voltage, and current, helping to pinpoint the location and cause of the open circuit. Begin by isolating the section of the loop that is suspected to be faulty. Disconnect the wiring at strategic points to narrow down the problem area. Use the multimeter to measure the resistance across the terminals of each device in the isolated section. A normal closed loop should show a low resistance value, typically close to 0 ohms, while an open circuit will show infinite resistance. Check the wiring connections at each device, including the duct detectors and test switches. Ensure that the wires are securely connected and that there are no loose or corroded connections. Also, inspect the wiring for any signs of damage, such as cuts, abrasions, or melted insulation. A faulty test switch can cause an open loop if the switch contacts are not making proper contact. Use the multimeter to test the continuity of the test switch in both the normal and test positions. The switch should have continuity in the normal position and should simulate a smoke condition when activated. The end-of-line resistor is critical for the proper operation of the fire alarm loop. If the resistor is faulty or missing, it can cause an open loop condition. Use the multimeter to measure the resistance of the end-of-line resistor and compare it to the specified value. If the resistance is significantly different, replace the resistor with one of the correct value. The wiring diagram provides detailed information about the connections and components in the fire alarm system. It shows how the detectors, test switches, end-of-line resistor, and other devices are wired together. By comparing the actual wiring to the wiring diagram, discrepancies or errors in the wiring can be identified. Understanding the fire alarm control panel is important. The fire alarm control panel is the central hub of the fire alarm system. It monitors the status of the detectors, initiates alarms, and provides enunciation. Become familiar with the panel's operation and the meaning of the different alarm and trouble signals. A fire alarm system is a critical life safety system, and it is important to follow all applicable codes and standards when installing, testing, and maintaining it. Consult the local fire codes and the manufacturer's instructions for specific requirements. Regular testing and maintenance are essential to ensure the continued reliability of the fire alarm system. Follow the manufacturer's recommendations for testing and maintenance, and keep detailed records of all work performed. If you are not qualified to work on fire alarm systems, consult a qualified electrician or fire alarm technician. They have the training, experience, and equipment to safely and effectively troubleshoot and repair fire alarm systems. When an open loop is detected in a fire alarm system, several steps can be taken to diagnose and rectify the issue. Firstly, visually inspect all wiring connections. Begin by visually inspecting all wiring connections in the affected loop. Look for any loose, corroded, or damaged wires. Ensure that all connections are secure and properly terminated. Secondly, use a multimeter to check continuity. Use a multimeter to check the continuity of the wiring between each device in the loop. Disconnect the wiring at each device and measure the resistance. An open loop will indicate infinite resistance. Thirdly, inspect the end-of-line resistor. The end-of-line resistor is crucial for the proper operation of the fire alarm loop. Ensure that it is properly connected and that its resistance value is within the specified range. Fourthly, test the duct detectors. Duct detectors are often wired in series within the loop. Test each detector individually to determine if it is causing the open loop. Disconnect the detector and measure the resistance across its terminals. Fifthly, examine the test switches. Test switches are used to simulate an alarm condition for testing purposes. Inspect the test switches to ensure that they are not stuck in the test position or otherwise malfunctioning. Sixthly, check for ground faults. A ground fault can sometimes cause an open loop condition. Use a megometer to check for ground faults in the wiring. Seventhly, consult the wiring diagram. Refer to the wiring diagram for the fire alarm system to verify that the wiring is correct. Ensure that all devices are connected in a proper sequence and polarity. Eighthly, replace faulty components. If any faulty components are identified, such as detectors, resistors, or wiring, replace them with new, approved component. Ninthly, verify the power supply. Ensure that the fire alarm panel is receiving the proper power supply. Low or fluctuating voltage can cause intermittent open loop conditions. Tenthly, document all findings and actions. Keep a detailed record of all troubleshooting steps taken, findings, and actions performed. This documentation will be helpful for future troubleshooting and maintenance. Fire alarm systems are essential for life safety and require regular maintenance and testing. Understanding the components and wiring of these systems is crucial for effective troubleshooting and repair. Always follow the manufacturer's instructions and local codes when working on fire alarm systems. When dealing with a fire alarm system, remember to prioritize safety. Always disconnect power before working on any wiring or components. Wear appropriate personal protective equipment, such as gloves and eye protection. If you are not qualified to work on fire alarm systems, consult a qualified electrician or fire alarm technician. They have the training, experience, and equipment to safely and effectively troubleshoot and repair fire alarm systems. Troubleshooting a fire alarm system involves a systematic approach to identify and resolve the cause of the problem. Firstly, gather information by reviewing the system's history, including recent alarms, troubles, and maintenance records. This can provide valuable clues about potential issues. Secondly, visually inspect the system components, including the control panel, detectors, initiating devices, and notification appliances. Look for any signs of damage, corrosion, or loose connections. Thirdly, use a multimeter to test the wiring and components for continuity, voltage, and resistance. This can help identify open circuits, short circuits, and ground faults. Fourthly, activate and test the system's initiating devices, such as smoke detectors, heat detectors, and manual pull stations. Verify that they are functioning properly and that the control panel receives the alarm signals. Fifthly, observe the system's notification appliances, such as horns, strobes, and speakers. Ensure that they activate and function as intended when an alarm is triggered. Sixthly, analyze the control panel's display and event logs. This can provide information about the specific devices or zones that are causing the problem. Seventhly, consult the system's wiring diagrams and technical documentation. This can help verify the correct wiring and configuration of the system. Eighthly, isolate the problem by disconnecting or bypassing sections of the system to narrow down the source of the issue. Ninthly, replace faulty components with new, approved replacements. Ensure that the replacements are compatible with the existing system. Tenthly, after making repairs, thoroughly test the system to verify that it is functioning properly. This includes activating all initiating devices and observing the notification appliances. Always follow the manufacturer's instructions and local codes when troubleshooting and repairing fire alarm systems. Proper training and experience are essential for safely and effectively working on these systems. It is very important to understand the types of detectors in a fire alarm system. Smoke detectors are designed to detect the presence of smoke particles in the air. They are typically used in areas where there is a risk of fire, such as living rooms, bedrooms, and hallways. Heat detectors are designed to detect a rise in temperature. They are typically used in areas where smoke detectors may not be suitable, such as kitchens, garages, and attics. Duct detectors are designed to detect smoke in the ductwork of heating, ventilation, and air conditioning systems. They are typically used in commercial buildings and other large facilities. Flame detectors are designed to detect the presence of flames. They are typically used in industrial settings and other areas where there is a high risk of fire. Multi-sensor detectors are designed to detect multiple fire indicators, such as smoke, heat, and carbon monoxide. They are typically used in residential and commercial buildings. In addition to the detectors, fire alarm systems also include initiating devices such as manual pull stations and sprinkler water flow switches. Manual pull stations allow occupants to manually activate the fire alarm system in the event of a fire. Sprinkler water flow switches detect the flow of water in the sprinkler system, which indicates that a fire is being suppressed. When a fire is detected, the fire alarm system activates notification appliances such as horns, strobes, and speakers. Horns are used to alert occupants of the fire. Strobes are used to provide visual notification for people with hearing impairments. Speakers are used to provide voice instructions and other information to occupants. Fire alarm systems are designed to protect lives and property. Regular testing and maintenance are essential to ensure that these systems are functioning properly. A clear understanding of the components, wiring, and operation of fire alarm systems is crucial for effective troubleshooting and repair.